Hello, what I'm going to be doing in this video is walking you through an exercise similar to the Chapter 2 assignment. So what we're going to be doing in this program is we're going to go ahead and write a program that calculates the average acceleration, which is defined as the change of velocity divided by the time taken to make the change, and it's as shown in the following formula. So you have your ending velocity minus your starting velocity divided by time, and that will give you your acceleration. So we want to write a program that prompts the user to enter the starting velocity, which is v0 in meters per second, the ending velocity v1 in meters per second, and the time span t in seconds, and it displays the average velocity. So I have some sample data that we're going to use after we've written the program to go ahead and test the program. So what we need to do is we need to get into JGrasp. So I have JGrasp open right now, and what I've done is I've kind of created a little stub right here called stub.java, and what that holds is just my public class and my public static void main, so I don't have to continually type that in. So I'm just going to do a copy, and I am going to go under my examples directory. I'll close this down. I'll click on File, and it'll be a new Java file, and then I'll copy that in. And the one thing I need to do is update my class name. So in the assignment, it said to name your class Acceleration. So I'm just going to go ahead and copy that class name over, delete stub, add acceleration in. There we go. So now we're ready to start our program. So the first thing when you read in this example, it asks you to write a program that prompts the user to enter the starting velocity. So if there's a program that directs you to prompt the user, the first thing that you should do in your program is to go into line 1. So I want to go ahead and add a couple of lines, and at the top of the program I want to add my import statement to go ahead and import my scanner class. So when you prompt someone, you'll always be using that scanner class. So the first thing I want to do always is to go in when I know I'm prompting the user is to add that import statement so that I can use the scanner class in my program. So the next thing we're going to do is we need to create a scanner object so we can go ahead and use it in our code. So I will just write out that statement. We have scanner input equals a new scanner object, and it will be a system.in. And then I have my closing semicolon. So now we have a scanner object that we can use when we prompt the user for the input. So the next thing, when they specify prompt, the first thing you'll want to do is you'll want to go ahead and add a system out print that tells the user what you want it inputted. So we're going to go ahead and write a system out.println, or a print, and what I'm going to do is I'm going to ask the user to enter the initial velocity, and that is v0 in our equation. Okay, so now I've prompted the user to enter the velocity. And then after the user enters the velocity, what I'm going to do is I'm going to save that input into a double. So if we look at the some of the test data, what we're doing is we're passing in doubles and we're outputting a double. So I want to make sure and store that in a double. And I'll call that variable v0. And then we need to add our input. And then it'll be a next double. So a common mistake is to get these messed up. So say for instance, if you wrote double v0 equals input next int and the user actually enters a double value, then what will happen is you'll get an error message. So you want to make sure that when you're requesting a double that you use the next double method, and when you're requesting an integer you use the input.nextInt method to grab that input from the console. Okay, so what we're going to do here is we're going to ask the user for v2 or v1, which is the ending velocity, and what I'm going to do is I'm just going to copy this down. Since I'm lazy, I don't like typing, so we'll just have them enter the ending velocity. It'll be v1, and then what I need to do is I need to make sure that I change my variable to v1. So I've asked the user for the initial and ending velocity. The final input I need from the user is the actual time. So go ahead, do a copy again here. So enter the time. And then I'll go ahead and save that in a variable called time. So if we go back to our program specifications, we want to write a program that prompts the user to enter the starting velocity, the ending velocity, and the time in seconds, and then it'll display the average acceleration. So now what we need to do is we need to calculate the acceleration based on the following program. So let me go back into JGrasp, and what I'm going to write is a double, and we'll use acceleration. When you name your variables, the variable name should be descriptive. You don't want to use X, Y, and Z. You want to use some type of descriptive variable within your program. The other thing you should be doing is adding in comments. So in the section above, gather input from user. And down here, what we're doing is we're calculating the acceleration. So our formula will equal our v1 minus our v0 divided by our time. So we'll go ahead and enter our formula, and then what we're going to do is we're going to display our output. Display the acceleration. And we'll do that with a system.out.println. And what I'm going to do is I'm just going to specify, again, when you display output, you should have some type of message that lets the user know what exactly you are displaying to the user. And then when you're concatenating in a println statement, when you're adding strings and variables to that, you must remember to add the plus sign. So that's another common mistake is, say for instance, if you're writing out a println and you're going to be adding text and variables throughout the print statement, you want to make sure that the strings are separated from the variables by a plus or the concatenation operator when it's used in a print line statement. Okay, so that looks like our program is ready to go. So what we're going to do is the first thing, we're going to go ahead and compile it. And then it'll come back and ask me for my name. I'll click on save. I'm going to save it under my examples directory. You can save it under wherever you would like. So I'll go ahead and click on the save button. And it looks like we have an error here. Okay, so it looks like I misspelled my acceleration. So let me go ahead and update that. So a little syntax error that I had, I will go ahead update that. We'll go ahead and recompile here. Okay, the program compiled fine. So what we're going to be entering for our input is 5.5. 50.9 and 4.5, and we should get an acceleration of 10.0889. So let's go ahead and run the program now. So I'll click on the little running man, go ahead and enter 5.5, 50.9, and 4.5. Ooh, and it looks like our acceleration is incorrect. So let's go back to our formula. So if we look at our formula, it is v1 minus v0 divided by t. So that's exactly what I wrote in my formula here. However, what we want to do is before we divide by time, we want to make sure and we subtract v0 from v1. So right now what it's doing, it's taking v0 divided by time and then it's subtracting that from our v1. So what I need to do is I need to add parentheses in here so that the v1 minus v0 is calculated first, and then after that we're dividing by time. So that is what you would call a logic error. Everything compiled, we didn't have any syntax errors, we didn't have a runtime error that results in an exception. What we actually did is we had an error, logic error in our formula. So what I need to do next is I'll just go ahead, recompile. It compiles fine. I'll rerun the program and I'll re-enter my input 5.5, 50.9, and 4.5, and I will go ahead and hit enter. And what it does now is it actually outputs my average acceleration. What I want to do is I want to go ahead and display it so there's 4 places to the right of the decimal. So let me just go ahead and copy and paste this statement, and I'll update it to use a printf. So in order to format the data, we can use a printf statement, and how I want to format the data is I want to go ahead, I need to specify my percentage so it lets the print line know that we're formatting our data, and then I'll add a point, and then the 4 means that I want 4 places to the right of the decimal place, and we're formatting a floating point number, and then instead of the plus concatenation, what we need to do is we need to add a parenthesis or a comma. Basically what it'll do is it'll substitute acceleration in this formatting that we've added here, the %.4f. So I will go ahead, compile the program and run the program, and I will go ahead, enter 5.5, 50.9, and 4.5. And now we see our formatted output where it's basically truncated things on to the right of the decimal, where it's only showing 4 places to the right of the decimal place. So this walks you through an example. So this example is similar, but not exactly like your programming assignment for Chapter 2. So we will talk to you later.